Hello again. Thanks for watching this video and studying math with me. Today we're going to discuss exponents. In the expression a superscript n, the number a is called the base and n is called the exponents, and a superscript n is read as the nth power of a. Now, we have many properties of exponents that you've studied before, and these theorems are only true if the bases are the same, but they are overall. So if I take a to the m times a to the n, we add exponents. If I divide a to the m by a to the n, we subtract exponents. And if we have am all to the nth power, we multiply exponents. And if we have ab, the whole parentheses raised to the nth power, we apply the exponent to both of the factors because things are commutative. These additional statements over here follow directly, but notice that we can not have 0 in the denominator in any case. There are a couple of additional principles of exponents. You may recall that a to the minus n is 1 over a to the n. Again, a cannot be 0. And a to the 0 power is 1, provided a is not equal to 0. 0 to the 0 power is undefined. And the order of operations work just as before. Given that exponentiation is repeated multiplication, this is where it falls. So you do parentheses, then exponents, then multiplication and division from left to right, and so on and so forth. Let's apply some of those principles of exponents to some problems then. Doing this first problem, I'm going to apply the square to both a minus a and x, and I have a to the 1 here, and I have x cubed. So a minus a squared is the same thing as a squared. So I'm going to have a to the first times a squared is a cubed, and this is going to be x cubed times x squared is going to be x to the 5th power. Now in the other example, what I'm going to have is the 5 is at the is the exponent for 2c, so that's going to be 2 to the 5th, c to the 5th, or 32 c to the 5th, all over, and I'm going to apply that 2 to the 3, the c, and the d. I'll get 9c squared d squared. But now I have c to the 5 over c squared, so I'm going to have 32c. I will subtract the exponents over 9d squared. And so those are some examples. Let's look at this next problem. It is important for students to realize that if 0 is the exponent, the base is 3x. We're assuming x does not equal to 0. That means that becomes a 1, and I'm going to multiply by a negative, and so that is negative 1. These next examples are a little more involved. C to the minus 3 in the denominator becomes c cubed in the numerator, and just as before, if 0 is the exponent, 7 is the base, and so that becomes minus 1, and the answer to that is minus c cubed. Now in this next example, the a to the minus 2 is in the denominator. Just as here, it moves to the numerator. And 3x, the whole thing, is the base associated with the exponent of minus 1, so that moves to the denominator. The 2 doesn't go anywhere because it's not being raised to a power. So we get this, and that is going to be a squared over, and 3 times 2 is 6x. Now, if we're doing calculations in Excel, multiplication is represented with a star, division is represented with a slash, and powers are represented by a caret. And we're going to do our final example in Excel and it's unit conversion. And so here's what we have. The acceleration due to gravity is 32.0. That's a measured quantity, feet per second squared. We want to express this as meters per square minute. What I'm going to do, and these conversion factors can be found in Appendix B, but I'm going to make these unit considerations on this and use Excel on the next chart. So let's talk about the units. 32.0 feet per second squared. Now, we need to change the second squared to minute squared, and we want it to cancel but have the minute squared in the denominator. So what we're going to do is we're going to have seconds in the numerator, we're going to have minutes in the denominator, but we're going to remember that there are 60 seconds per every minute, but then I will square those. That will give me minutes squared in the denominator and seconds squared in the numerator, which is what I want the second squared to cancel with that. And then we have to change feet into meters, and it is known that there are 0.3048 meters in 1 foot. So what will happen is the feet will cancel with the feet, the second squared will cancel with the second squared, and our answer is going to then be meters per minute squared. Now we have to do the numbers, and let's talk about how we will do the numbers in Excel. So here, what I'm going to do is, there's my 32.0, there's my 60, and there's my conversion factor. These two are exact. That is a measured quantity. So what I'm going to do is I'm going to make a formula equals. I click on C1 to get 32. There's my multiply, which is the asterisk. Then I click on D1, the exact value, 60, and I have to square that one. There's the caret 2. And then I'm going to click on the E1, and I'm multiplying that. So when I do that calculation, I get this number. But then I have to realize that this number was exact, this number was exact, but this number was approximate and has 3 significant digits, so I have to turn this into 3 significant digits like we did in the previous chapter, and so the answer is going to be 35100, and that's going to be the answer to the problem that we started on the previous page. Now, in class, we plan to work on several more problems from your textbook, but serious students will want to do more, including reading the section and completing additional work. But for now, remember that time is precious. Each day must count. Do the math. It will make you strong.